Alright guys, example, find a unit vector in the direction of the following. Okay, so we're going to be taking two of the versions. So let's take A and D, and then of course I usually take this as classwork. So we have 2I minus 3j plus k. So let's say for A, let's A, okay, let's vector A equals to 2I minus 3j plus k. So modulus of A will be equals to square root of 2 square plus minus 3 square plus 1 square, which is square root of 4 plus 9 plus 1, which is square root of 14. Okay, so therefore the unit, A unit, which is A all over magnitude of A, will be equal to 2I minus 3j plus k all over square root of 14. So you don't need to split it, you can always leave the answer this way, because when you break it down, it become a direction cosine. Okay, so we have the other one, minus 1, 2, minus 3. So let's say for C, let's call that C. Vector B equals to minus 1, 2, minus 3. So that modulus of B will be equal to minus 1 squared plus 2 squared. Okay, and this is 1 plus 4 plus 9, which is the same thing, 14. So that B unit will be equals to B all over modulus of B, which is equal to 1 over root 14 minus 1, 2, minus 3. So that is what we have. Okay, so you can write unit vector in unit form, in a component form, and then in column form. Okay, right guys, so example 8, if the following pairs of vector are equal, find the value of A, B, and C. So we can use equality in a term to solve problems. So I'm going to be doing only one. So solve the first one as classwork. Let's do B. So for B, so if they are equal, then we have A minus 1I plus B plus 2J plus CK will be equals to minus BI plus A minus 1J plus 2CK. Okay, so we are going to equate the components I to I. A minus 1, coefficient of I, A minus 1 will be equal to minus B. Coefficient of J, we have B minus 2 equals to A minus 1. And coefficient of K, we have C equals to what? 2C. Okay. So if C equals to 2C, what are we going to have? So we can solve this one first. So if 2C equals to 2C, we can have that 2C minus C equals to 0. So 2C minus C is C, so C equals to 0. From here, let's say here, here. If we substitute minus B for A minus 1 in the second one, we're going to have that B minus 2 equals to minus B. So B minus 2 equals to minus B, so that B plus B equals to 2, 2B equals to 2, so that B equals to 1. Okay, and we have A minus 1 equals to minus B, so A equals to minus B plus 1, so A equals to minus 1 plus 1, so A equals to 0. Okay, so therefore we have A equals to 0, B equals to 1, C equals to 0. Okay, so this is how you go. So to use equality of a vector to solve problem, you basically equate the coefficient of the I, J, and K. And here you see that if you solve this one, you have a equals to 3, b equals to -4, and c equals to 1. Okay, so that's what we're going to basically have. Alright guys, hope you are following. Parallel vector from parallel lines. So you know parallel lines are lines that can never meet, but they can have the same magnitude and direction. Okay, so a parallel vector, to multiply a vector by a scalar, we multiply each component by the scalar. So any vector obtained by multiplying another vector by a scalar will be parallel to the original vector. So we obtain parallel vectors by multiplying the original vector by a scalar. If you multiply a scalar by a vector, or you multiply a vector by a scalar, the answer will always be a vector, and the answer you have is said to be parallel to the original vector. Okay, so here we have 2, 3, 4, 5. 3, 4, 5 is a vector, 2 is a scalar. When we multiply, we have 2 times 3, 6, 2 times 4, 8, 2 times 5, 10. Okay, and then you can do it in component form. 2 bracket 3i plus 4j plus 5k. That's 2 times 3i, which is 6i, 2 times 4i, which is 8j, 2 times 4j, which is 8j, 2 times 5k, which is 10k. Okay, so now 6i plus 8j plus 10k is parallel to 3i plus 4j plus 3k, and that is parallelity. So we can just see parallelity as the result of scalar multiplication. Okay, the result of scalar multiplication. So that's parallelity basically. Alright, let's see example. Find the values of C for which the following vectors are parallel. Find the values of C for which the following vectors are parallel. So let's start from A. We have I minus 2j plus 4k. Okay, they are parallel, right? And then we have, let's say this is A and this is B. 0.5i uh, minus cj plus 2k. So to find parallelity, we just find a way of writing either the first vector as a scalar multiple of the second one, or the second one as a scalar multiple of the first one. So let's see what we can do. So you can see that in the first one we have I, 1i, in the second one we have a 0.5. So what has happened there? So that is division, multiplication by 1 over 2, right? So here you can see that, let's analyze very well. Alright, so if we analyze very well, we'll see that A equals to just like what? 2 multiplied by B, which is 2 multiplied by 0.5i minus cj plus 2k, and that is equals to I minus 2cj plus 4k, right? Good, plus 4k. Okay, so what do we have there? We are asked to find the value of c, right? Find the value of c. So what do we obtain in that place? So it then means basically that let's clean c here, since this one does not actually have c. We found the parameter we are looking for, so this is c. So it then implied that, what do we have here, that c is going to be equal to 2. Yes, okay, so c equals to 2. C is 2. Okay, c is 2, because if we divide the first vector by 2, we are going to get the second vector basically. So I think we should always be using the one that has complete a solution to find it, so we can solve from A to B here instead. So let's look at the equation we have in B. Minus 15, 36, 21. So we have B A equals to minus 16, 36, 21, and B equal to minus 20, 48, 48C. Okay, so which one is complete? A. So let's solve from A. From A, let's study the parameters. Study the parameters. We have a minus 16 here, so does it make sense? Minus 15, rather. Minus 15. So this is minus 15. So we have minus 15, 36, 21. So what is the relationship between minus 15 and 36 and 21? What can we see from there? So it seems this is an addition instead of something. So if we study it very well, what relationship can we have from those parameters? Okay, so here let's do something strange here. So you can see that if we do 3 over 4 multiplied by minus 20 over 1, so 4 here 1, 4 here 5, this answer will give us minus 15. Does it make sense? So if we do 4 over 3 times minus 15, 3 here 1, 3 here 5, minus 5, so the answer will be minus 20. Good. So if we multiply the first vector by 4 over 3, we're going to obtain the second vector. You notice? So let's work it out. So vector A is equal to 4 over 3, or rather, let's say vector B. Vector B equals to 4 over 3 multiplied by vector A. Do you agree? So let's work it out here. So it then implies that vector B will be equals to 4 over 3 multiplied by, what is vector A? Minus 15, 36, 21. And that will be 4 over 3 multiplied by minus 15, 4 over 3 multiplied by 36, 4 over 3 multiplied by 21. Okay, and that will be equal to 3 in 15 is minus 5, so we have minus 20. 3 in 36, that is what? Or 12. 12 times 4, that is 48. 3 in 21, that is 7. 7 times that's 28. So if we compare the values, we have minus 20, minus 20, 48C is equals to minus 20, 48, 28. Okay, and therefore C equals to 28. So this is how you solve of parallelity. Okay, parallelity is a little bit complex than equality because you have to manipulate the scalar multiplication to obtain the value. So take note, guys, this is how you solve those. So 3 here, 3 here, minus 5, 3 here, 3 here, that's 12, 3 here, 3 here, that is 7. Okay. Alright guys, let's move forward. Hope you are getting the other ones.